Good morning everyone. Today's the topic is blood pressure. So blood pressure is not a disease. It is a parameter by which we can measure the force exerted by the blood in the inner wall of the arteries. Okay. The definition is blood pressure is it is a measurement of the force applied to the artery wall. Here is the artery. See, this is the inner layer. So when the blood is moving through this artery, so it's exerted pressure to the inner wall of the artery. Normally, blood is not moving steadily throughout as in we see in pipelines etc. The water is moving steadily, but in blood is not moving steadily. It's seek a pressure. It needs a pressure or push. The heart has to push, give a impulse. That's like a push. That the blood moves from the aorta, artery, arterioles, and the other body part. So this pressure is exerted by the blood in the inner wall of the artery. It's called the blood pressure. So again the term where is the force is the term force where is come. The force is the fluctuating force. What is that? It's not a constant force. It's maybe rise or maybe fall. That blood exert against the arterial, against the arterial. Okay, as the heart contracts and relax. So as the heart contracts and relax, that's in that same manner it's give a force to the inner wall of the arteries. So before come to know about contractions and relaxation of heart, I want this briefly discuss the what is blood circulation. It is our human heart. So in here our heart is divided into four chambers. One is on the this is the right side and this is the left side. In left side it is divided into in the right side divided into right atrium and right ventricle. In the left side is in same manner, that is left atrium and the left ventricle. Usually this left side carry deoxygenated blood of our body. This right atrium receive blood from the lower part of the body, that is inferior through the inferior vena cava, from the upper part of the body by the superior vena cava. If this blood is collected here on the right atrium by the valve, that is AV valve, this moves to the right ventricle. It's not directly moved. It's need a push that is created by the impulses, the electrical impulses created by the SA node. In that it is also called a natural pacemaker that gives the electrical impulse. So it helps to force the blood from right atrium to right ventricle. Again, when the water, this chamber is filled with blood, this valve is closed. Okay, so in this contraction, again the contraction is taken in the ventricular valve. This contraction is created by the SA node through these ventricular valves. It's the contraction, the same electrical impulse through these ventricular valves helps to contract the ventricle. By this, the blood moves from the left ventricle to the valve to the pulmonary artery. What is that? Artery, usually all the arteries are carrying oxygenated blood, but there is an exception in the pulmonary artery. It carry only one, that is carry deoxygenated blood. So the blood from the right ventricle through the pulmonary artery, it goes to lungs. Here there is lots of air sacs present in the lungs, that is called alveoli. The blood come in the deoxygenated blood that is rich in carbon dioxide. It's exchange process. The process of exchanging takes place in the lungs. Again, the oxygenated blood is come through the pulmonary vein to the left atrium. So our left atrium is carrying oxygenated blood. After gaseous exchange between the blood, this oxygenated blood moves to the left atrium through the pulmonary veins. Again, from this pulmonary valve, through this opening, it's entered into the left ventricle. Again, due to the same contractions that created by the SA nodes, it's push the blood, it give a push the blood, it's moved to the aorta. Aorta is the aorta carry it gives blood to different part of the body through the branches. Okay, so this is all about our blood circulation. Here two terms are coming in this blood circulation. The contraction. So the contraction takes place. Contraction takes place on the heart, that helps the exert a pressure to the blood to move through the artery, aorta, then artery, then arterioles. So the contraction is called the systolic pressure. Usually see in this figure, when during the time of contraction, the heart becomes squeezed, so that the blood is forced to move to this opening to come out. But in diastole, what? It's a relaxation. Relax means the after each contraction, the heart muscles relax to refill of blood. So this is the filling. The blood from the upper lower part or the pulmonary body that enter into the chamber of the heart. That is the diastolic pressure. Okay. So how we measure blood pressure? The measurement instrument is called sphygmomanometer. It is a inflatable cup that is attached to the upper arm of our hand, and another end is attached to the gauge, giving on pressure to that apparatus. So we can hear the first contraction sound. Okay, the first contraction we can hear by the stethoscope. That is the systolic pressure. That is the contractions. After fraction of a second, we again hear another sound, that is diastolic pressure, or that is the diastolic pressure. By recording these two parameters, systolic pressure and diastolic pressure, we get the blood pressure reading. This contractions, normal systolic pressure is 120 mm of Hg. In the diastolic, the normal range is 80 mm of Hg. You see on the blood pressure, two parameters are written up and down. The upper one is, or the top number is always systolic pressure. The bottom or the lower number is the diastolic pressure. What is the normal? This is the blood pressure that is normal reading. Normal is 120 to 80 mm of Hg. There is also normal range for the blood pressure. The normal range is below 120 mmHg, and in that case diastolic is 80 mmHg. If it is elevated, in certain case you see over stress, excitement, anxiety, blood pressure level increases. So the systolic increase 120 to 129. It reaches 120 to 129 mmHg. But the diastolic you see, that is below 80 mmHg. Then high blood pressure. High blood pressure, also known as hypertension. It is are of two types, stage 1 and stage 2. In stage 1, what happens? The systolic pressure rises from 130 to 139 mmHg, and the diastolic also increases elevated, that is 80 mmHg to 89 mmHg. So in stage 2, it is the systolic pressure rises 140 mmHg to higher level. Okay. Similarly, the diastolic also increases 90 mmHg to high level. These two, stage 1 and stage 2 it's a very serious matter. If the blood pressure, always blood pressure is not remain constant throughout the day. It may be fluctuate on the daytime or any exercise, or if you take rest, it become decreases. So different body activity that we do in the day, throughout the day. So throughout the day duration, the blood pressure is fluctuating, changes. So if continuously blood pressure stage 1 and stage 2, as I told, the systolic pressure increases, diastolic pressure, if they continuously taking blood pressure reading, you get the same result. So we must consult to the doctor or the physician for the treatments. And the last one is hypertensive crisis. In that, what happens? The blood pressure systolic level is rises above 180 degree. 180 mm of Hg, and the diastolic is above 120 mm of Hg. It is a serious condition. It needs emergency treatment. Okay. Then on this video we see about the blood pressure. In the next class we will discuss about the hypertension. Okay, high blood pressure. Okay, thank you.